Thought I would do some of the problems from your chapter review since we didn't have a chance to today. So the first one I picked is question 3. This is from section 4.1 on parabolas. And so they give us the function. They ask, how does it open? And this is determined by your coefficient, the sign of the coefficient actually. It is negative, so it's going to open down. When you are in this form, your vertex is negative b over 2a, and then you plug that back in to your function. So negative b would be 56 over 2 times negative 4, so 56 over negative 8 will give us negative 7. And then we want to do f of negative 7 to get the y-coordinate. So we have negative 4 times negative 7 squared minus 56 times negative 7 minus 192. And then we'll do this on the calculator. So negative 4 times 49. You had to do that exponent first. Pull the calculator up. So negative 4 times 49, enter, negative 196. This will be plus 56 times 7, or you could have done your signs with it in the calculator. So plus 392. And minus 192. So I've got 392. I'm going to do minus 196 minus 192. Enter. And I get 4. So your vertex of the parabola is negative 7, 4. And we can check. Opens down. Vertex is negative 7, 4. Make sure that you know this formula. This is the x-coordinate. Whatever your answer is what you plug in to get the y-coordinate of the vertex. When it opens down, you get a max. That's the next question. Then they ask for the x and y intercepts. Y-intercept is the easy one. You plug 0 into x, so 0 into x is going to wipe these out. It will give you just your constant. So it will give you 0, negative 192. So not a lot of work there. X-intercept, you have to set y equal to 0 and solve, so this one is more work. Hopefully we can factor out a negative 4 on this one, so that it'll be easier to solve. And we pull the negative outside, so this will make a positive 14x, and we pull the negative 4 outside, it leaves positive 48. And we want things that multiply to give 48, combine to give 14. 6 and 8 do. So you can factor there, like signs both plus. So plus 6 plus 8, it wouldn't matter which one. And then you're going to set each of these equal to 0 and solve. There's no variable with your negative 4, so it's not going to matter. So this will be x equals negative 6 and x equals negative 8. So negative 6, 0 and negative 8, 0 are your x-intercepts. Y-intercept, 0, negative 192. X-intercepts, negative 8, 0, negative 6, 0. We're good there. Next, they ask for the axis of symmetry. This goes back to your vertex. and it is the x-coordinate of your vertex. So x is equal to -7. That is from the vertex. It's easier when you can see this all in one shot. Now, they want us to draw the graph. You need the vertex first. So we'll hit the tool. We'll do the vertex, which is -7, 4. And then we need to draw 1 point. So we can do -6, 0. So it does open down. We have a max there. They ask us for the domain. Easy to take from your picture. A parabola that is vertical. The domain is going to be -infinity to +infinity. This side will keep going down, and to the left, this will keep going down, and to the right. So -infinity to infinity. And I am assuming the next question is the range. So lowest to highest, you're coming from -infinity to your highest point is 4. -infinity to 4. You touch the 4, so you're going to need a bracket there. So our domain, -infinity to +infinity, range, -infinity to 4. Next, we'll look at question 4. It is also a parabola, but this one is in standard form. And our standard form, the general form, is x minus h squared plus k, and hk will be your vertex. So first we'll pick off our vertex. This is already minus, so it will be 2, -1 for the vertex. This one is going to open up because it's a +1 in front. So there could be an A here. And if it's positive, it opens up. If it's negative, it opens down. So this one opens up. We already did the vertex. Your y-intercept, plug 0 into x. So you have to do a little bit of work here. So you get -2, and you're going to square it, which gives you 4 minus 1 is 3. And we plug 0 in for x. So 0, 3. And we can check these. So it's going to open up the vertex to -1 and y-intercept 0, 3. X-intercepts is to set 0, so 0 in for y, and it is x minus 2 squared minus 1, and you're going to solve with the square root method. So add your 1, so you will get 1 equals x minus 2 squared. Take the square root of both sides to get rid of this exponent. Remember, on this side, you'll get plus and minus. On this side, your exponent will come off. All right, square root of 1 is 1. And now you're going to add your 2. So we'll add 2. We're going to put it in front of the plus and minus. So 2 plus 1 gives us 3, and our y is 0. 2 minus 1 gives us 1, and the y is 0. So these are the x-intercepts. And they want the axis of symmetry. This goes back to your vertex, which we said is 2, -1. It's the x-coordinate of the vertex. So it is x equals 2. And now we'll draw the graph. So first you're going to enter your vertex. Which we said is 2, 2, -1. And then we'll use one of the y-intercepts. So we can use 3, 0 is fine. And there's our picture. The domain, it will also be -infinity to +infinity. Keeps going forever to the left, forever to the right. Your range, this one has a lowest point, which is your vertex. And you're looking at the y-coordinates with range. You are touching it. So it is -1, and it goes forever up. Next, we'll look at question 6. It says, consider this function 12 minus 32x plus 16x squared. Determine without graphing whether the function has an absolute maximum or minimum. First of all, I would turn this around to descending order. And this is a parabola. So the first thing you want to know is the sign of your leading term is positive. And so positive says that it is going to open up, which says that you are going to have a minimum. And the minimum will be at the vertex of the parabola. So we want to find the vertex. For this one, you should use the formula. Negative b over 2a for the x-coordinate. So that will be positive 32 over 2 times 16, which is also 32, equals 1. And then we have to do f of 1. So 1 squared is 1 times 16 is 16 minus 32 plus 12. This will be negative 16 plus 12 is a negative 4. So our vertex is 1, -4. You have to be careful when you answer this one. It occurs at the x value. So it is where it occurs is that x equals 1. The value of it is the y value. So to answer this one, the function has a minimum of, so they want the value first, -4. We'll just look. -4, and it occurs at 1. For your domain, a parabola that is vertical in orientation is -infinity to +infinity. For your range, we'll work with the vertex. We said the vertex is 1, -4, and we have a minimum. So that is the lowest point, and it will go up. So the y of the vertex, -4 to infinity. Next, we'll have a look at question 7, a word problem. And so the height in feet of a ball thrown from a child is modeled by the quadratic equation. And this gives us a parabolic pathway. Here is our function. X is the horizontal distance in feet from the point at which the ball is thrown. The ball is thrown from right here. Use F to answer the following questions, round if necessary. How high is the ball when it leaves the child's hand? So what you want to know first is what is the y-intercept? And to get the y-intercept, plug 0 into x. That one is very easy to do by hand. 0, 0, so it is 3. So 0, 3, so it is 3 feet when it leaves the hand. How far away from the child does the ball reach its maximum height? Its maximum height will be the vertex, and you want to know the x-coordinate. That's how far away of the vertex. You can get that fairly easily by hand, or you can also go to your calculator. We'll go ahead and do that one by hand. So it is negative b over 2a. So it is negative 2 over 2 times negative 1 over 14. And this is negative 2 over negative 1/7. And you would change this to multiplication and this would flip. So you have negative 2 times negative 7. So this gives us a positive 14 for the x of the vertex. Now you can plug this in to get the y of the vertex, which is your maximum height, which is the third question. So you could do it by hand. So f of 14 and just a little bit messy. Your 14 squared, and then you're going to divide it by 14, so it's actually just going to go back to 14. But so 14 squared, just to show that we're following order of operations, times negative 1 over 14 gives us back a negative 14 plus 28 plus 3, and this would give us 14 plus 3 is 17. So the maximum height will be 17. So this should be 14, 17. Let's just pull the calculator up for a minute. On several of these, the calculator, you have to really play with the window to make the calculator work. I typed this in already. So let's say graph. And we're going to see that we are not going high enough. So we need to change our maximum y value. We also need to change the maximum x value. This is the point of release that we can see right here. So let's change this window some, and we really don't need any of this negative part. So let's change our x max. Let's go out to 30. And we wanted to change our y. Let's take it to 30. We should be okay with that. Now let's draw the graph and see what we get. All right, there we go, a nice picture that we can work with. So if we want our vertex from the graph, this one you would still have to do by hand. Vertex from the graph is second calc. It would be a max, so 4. You have a left bound, you're good there, you're to the left of it. Then move your cursor over clearly to the right of it. And enter. And there we go, that is the vertex. This is just round off error in the calculator, so 14, 17. If you had the 14 by hand and you just didn't want to calculate this part with your function typed in, you could have just gone into second calc value and put the 14, and it would give you the answer of 17, right? And we have one more question, and that is how far from the child does the ball strike the ground? That is over here on your picture, which this is going to be your x-intercept. This is not one that I really want to solve by setting it equal to 0, so we're going to try to use the calculator here. Really would probably be better if my my x max was a little bit more. I'm going to change the x max a tiny bit and make it 35. Just give me a little bit more room there. All right. And so what I would like to find now on the calculator is this point. That's where it's going to hit the ground. How many feet from where the child threw it? So this will be called a 0. So do second calc. 0 is an x-intercept. So 2. And we want to get over there close to it, but to the left of it to make a left bound. So we're clearly to the left of it. Enter. Now we want to get to the right of it. All right, we're clearly to the right of it. And then just click enter again for guess. And so for this value, we have 29.4272. And let me scroll this down just a little bit. Didn't want to go that much. Just wanted a little space. All right, so from the calculator, my x-intercept is 29.4272. They said to round to 3 decimal places, so you need to see 3, you need to see 4, and then this one, it will either push you up or drop off. So a 2 is lower than 5, it's going to drop off. So 29.427 feet is our next answer. We'll look at one more review problem from section 4.1. And this is another word problem. You will have a word problem on your test, and it will be one of these 2 types. So we are going to put some fencing around this pen, and we don't need any fencing against the barn. So we're going to fence 3 sides. We really don't need their labeling. We're going to work on this in terms of W, which is the width. So this will be W and this will be W. Now, we would like to get an expression for the length in terms of W. So if you have 450 feet fencing total and you take off these 2, that will give you an expression for this one. So 450 minus 2W. Then you have something in just one variable. So first they want our formula for the function a of W, and area of a rectangle is length times width. So we have 450 minus 2W times W. And you could work it out. So 450W minus 2W squared, or you can also change the order there. So that is your first answer for your function. And I don't think it matters which form you put in. Right now we want to find the width and the length that would maximize the area. This is a parabola. and it has a negative leading coefficient. This is your first term. So it is going to go down, and you want the maximum of that parabola. You can use your formula, negative b over 2a, to get the x-coordinate. Right, and I'm just going to switch this order to make it a little easier picking these off. All right, so negative 450 over 2 times negative 2. So negative 450 over negative 4. And this gives us a positive 112.5. And that will actually be your W, the x-coordinate of your vertex there. So that will be your width. For the length, I think the easiest thing is just to plug into this one, the value that you found. So length is 450 minus 2 times 112.5. And we will multiply before we subtract. This gives us 225. So 450 minus 225 gives us 225. So our width, we'll make these red, is 112.5. Our length, which will maximize the area, is 225. So those are our first questions. This is for your formula. It should also accept it if you worked it out to this form, either of these two. Your width, 112.5. Your length, 225. So we're good there. I should have put feet on there. And now they want the maximum area. There's two ways you could find the maximum area. The fastest way, in my opinion, is to use the formula for area, which is width times length, and just use these numbers. And our length, we said, is 225. Our width is 112.5. And if we multiply that, we get 25,312.5. And this is in square feet, because we did feet times feet. I think that's the fastest way to do it. You also could have plugged in your x value into your function to get the y of the vertex, which is going to be your value of your max, and it will give the same answer. So if different way, same problem. So negative 2 times 112.5 squared plus 450 times 112.5. And so we'll do our math, and I did it all in one shot, so you'll have to bear with me here. So this one gives us 12656.25, and then we're going to do times negative 2. So I squared this one, which gives us negative 25312.5. And then we're going to add 450 times 112.5. So I should just pull this up for you guys. This one would not work nice in your calculator. So 450 times 112.5 equals 50,000 625, and then we will subtract 25312.5. And we come out with the same answer as we did going the other way. It's 25312.5, and this is in square feet. We'll double check our answer over here. So we're good.